Hello everyone and welcome. We're going to do a complete and quick revision of the entire chapter on light. We'll be hitting all the core concepts you absolutely need to know for your exams. So let's get right into it.
Okay, here's our game plan. We'll kick things off with mirrors and how they reflect light to form images. Then, we'll jump into the world of lenses and see how light bends. And finally, we'll do a rapid-fire revision of all the essential formulas to lock them in.
Right, let's start with reflection. It's basically what happens when light hits a polished surface, like a mirror, and bounces off. It's something you see every single day.
Now, when we talk about spherical mirrors, there are two main types you need to know. First, the concave mirror, which curves inwards. A good way to remember this is to think of it like a cave. The other one is the convex mirror, which bulges outwards.
And this image shows you exactly what they do. A concave mirror is a converging mirror. See how it takes all those parallel rays of light and brings them together at a single point? That's its job. A convex mirror, on the other hand, is diverging. It does the opposite, spreading the light rays out.
So the big question is, how do we figure out where an image is going to form? For that, we use something called ray diagrams. And don't worry, they're pretty straightforward once you know the rules. There are just 3 simple rules you need to master.
Okay, rule number 1. Any ray of light that's traveling parallel to that main central line, the principal axis, will always reflect and pass through the principal focus, which we label with a capital F. Now, here's a crucial tip for your exams. You must draw arrows on the rays to show which way the light is going. It's a small thing, but you can lose marks for it.
Rule number 2 is literally just the reverse of rule 1. This time, if a ray passes through the focus before it hits the mirror, it will bounce off and travel parallel to the principal axis. See? They're just mirror images of each other. Easy to remember.
And finally, rule number 3. If a ray of light passes through the center of curvature, C, it hits the mirror and reflects straight back along the exact same path it came from. Now, why does that happen? Because it's hitting the mirror at a perfect 90-degree angle. It's like throwing a ball straight at a wall, it just comes right back at you.
Now, once you know those rules, you can predict exactly what the image will be like, which is what this whole table shows. But hey, don't just try to memorize this. Look for the pattern. For a concave mirror, as you move the object closer, the image gets further away and bigger. And it's almost always real and inverted, except for that last special case, which is exactly how a shaving mirror or a dentist's mirror works to give you that magnified view. Drawing ray diagrams is a great skill, but sometimes we need an exact number. And for that, we have the mirror formula. This is a super powerful tool that lets us calculate the precise position of an image without drawing anything at all. And here it is. 1 by V plus 1 by U equals 1 by F. This is the famous mirror formula. It connects the image distance, V, the object distance, U, and the focal length, F. This formula is absolutely fundamental to this chapter.
But before you start using the formula, you have to understand this, the sign convention. This is so important. Just think of the pole of the mirror, P, as the origin on a graph. Any distance measured to the left is negative. Anything to the right is positive. Since we always place the object on the left, U is always going to be negative. Getting your signs correct is honestly half the work done.
Okay, so we've covered how light bounces off surfaces. Now let's switch gears and talk about what happens when light passes through a transparent material, like a lens. This phenomenon, the bending of light, is called refraction.
So what is refraction in simple terms? It's just the bending of light. And it happens because the speed of light changes when it goes from one medium to another. For example, when light goes from air, which is a rarer medium, into glass, a denser medium, it slows down and bends towards the normal. When it comes out, it speeds up and bends away. And just like mirrors, we have 2 main kinds of lenses. We have convex lenses, which are thicker in the middle, and we have concave lenses, which are thinner in the middle and thicker at the edges. And you can see here they behave in a very similar way to their mirror counterparts. A convex lens acts like a concave mirror. It's a converging lens that brings light rays to a focus. And a concave lens acts like a convex mirror. It's a diverging lens that spreads the light out. Now take a look at this table for a convex lens. Does it look a bit familiar? It should. It's almost identical to the table for a concave mirror. You see the same pattern. For most positions, you get a real inverted image. And again, you have that one special case when the object is really close where you get a magnified virtual image. This is exactly how a magnifying glass works. No surprises here. Just as we had a formula for mirrors, we've got one for lenses too.
Plus, we're going to introduce a new concept called the power of a lens.
Here is the lens formula. Now look closely. It seems almost the same as the mirror formula, but there is one massive difference. Can you spot it? It's that minus sign. It's so easy to mix these two up in an exam, so please be careful, and remember, lens has a minus.
So what's this power of a lens? Well, it's basically just a measure of how strongly the lens can bend light. A lens with a very short focal length is really good at bending light, so we say it has a high power. And the unit we use is the diopter, which you might have heard of if you've ever had your eyes tested.
All right, we're almost at the end. Let's do one final quick revision of all the key formulas from this chapter. This is the slide you'll want to take a screenshot of for your last-minute prep.
Here it is, your entire formula list on one slide. Look at the differences carefully one last time. The mirror formula has a plus, the lens formula has a minus. The magnification for a mirror has a negative sign, but the one for a lens doesn't. Knowing these small details inside and out is the secret to getting all your numerical problems right.
And I'll leave you with one final question to think about. We know that refraction is the bending of light. That's why a pencil looks bent in a glass of water. But that same principle is at the heart of how a rainbow forms. So my question is, if sunlight is white light, how does simply bending it create all those beautiful colors? Think about it. There's another related phenomenon happening there. What could it be?